Hello, hello, hello. Welcome back to another round of Izzo teaching squirrel proofs. Squirrel may or may not be napping. We will see if she chimes in. Today, we are doing well. Squirrel and I are still very healthy. There is no corona anywhere here. We're having fun. The snow yesterday is pretty cute. Yeah, that's the full report. Okay, so for these proofs, we need that sheet from your bright green vocabulary packet that probably none of you have. So we're gonna do that. We started with the quadrilaterals. That was on top, so quadrilaterals was on top, and quadrilaterals were anything with four sides. That doesn't look like quadrilateral. There we go. That's a beautiful quadrilateral. Okay, and then there were three types of quadrilaterals. There were the kites, and kites look like this. Maybe? No? Try again. It looks too much like a rhombus. Let's try again. Nope. I'm really bad at drawing these. Oh, Squirrel has joined us. Still a rhombus. Gosh darn it. Okay, well, it looks sort of like this. Symmetrical. Got that on the side. There we go. Okay, then we got the trapezoid family. Trapezoid family looks like nope. What is with my snap tool today? It does not like me. Ink to shape. Please ink it and shape it. Okay, good enough. Trapezoid. And there were two different types of trapezoids. There was either the right trapezoid or the isosceles trapezoid. And that was looking like that or looking like that. Beautiful. And then we have the parallelogram family. Parallelograms, of course, are looking like this. And there were two types of the parallelograms. There's the rectangle, which looks like that. Really? The rectangle didn't work? I was really bad at this today. Okay. And the rhombus. Watch, it won't actually draw a rhombus now that I want a rhombus. It won't. Okay. And when a rectangle and a rhombus love each other very much, they make a square. I know that's inappropriate, squirrel, but that's how it works. Okay, so let's start with the kite. Very rarely will kites ever be on the regents, but I need to teach it to you anyway, just in case. So kites, there are four properties. 1, 2, 3, 4 properties for a kite. Kites, we've got consecutive, sides are congruent. Consecutive means next to each other. So if we take a look at my kite, still looks like a rhombus. Gosh darn it. If we take a look at my kite, this side and this side should be congruent, and this side and this side should be congruent. Opposite sides are not congruent. Nope, no congruent. And that would be meaning these two sides, not congruent. Diagonals are perpendicular. So if I were to draw in some diagonals here, they would make nice right angles. Diagonals go straight through the shape. And then we've got one pair of opposite angles are congruent. So that would be this pair right here. This is congruent to this. These two are not congruent. This one on top is fatter than the one on the bottom, when we don't know by how much. So that's what we got for kite. Let's take a look at trapezoid. I'm going to go on to the next page for trapezoid. Okay, so I can probably fit it here. We'll try to fit it here. Okay, trapezoid. Trapezoid only has one possibility. A trapezoid is one pair of opposite sides parallel. That's it. So normally looks like this, where we've got this side and this side are parallel, and that is it. That's all we got. Yes, but trapezoids have two different types of trapezoids. There's the right trapezoid and the isosceles trapezoid. So the right trapezoid is, of course, a trapezoid, yes. And it has a right angle. Good job, squirrel. I know, you're very smart. So number one, it is a trapezoid. So it does have that one pair of opposite sides parallel. And the second thing is it has two 90-degree angles. No, not 290-degree. No, it does not say 290-degree angles. It says two angles that are 90 degrees. Is that better? She thinks that's better. Okay. So that would be a right trapezoid. Right trapezoid, of course, looks like that. And then let's take a look at the isosceles trapezoid. The isosceles trapezoid does not look like a circle. Let's try again. Isosceles trapezoid is, of course, a trapezoid. So it has the one pair of opposite sides parallel. It also has 2, 3, 4. The second thing, non-parallel sides are congruent. This is an isosceles trapezoid. Isosceles trapezoids looking like this. So we've got parallel sides on top and bottom, just like the regular trapezoid. And then the non-parallel sides are congruent. So this side is congruent to this side. 3 says, well, when we have isosceles, we've got two pairs of sides congruent. We also have, we have one pair of sides congruent and one pair of angles congruent. In this case, we're actually going to have two pairs of angles, consecutive angles congruent. So this angle and this angle, but also these top angles are going to be congruent. And then we've got diagonals are also congruent. So if I were to cut through the shape like this and like this, those diagonals would be congruent. Okay, so those are our trapezoids. They sometimes ask about trapezoids. It's about 50-50 that they ask about trapezoids. I don't think I've ever seen them ask about kites. 100% of the time, they ask about our favorite parallelograms. Parallelograms, extremely, extremely important. So we've got parallelograms, and we've got 6 different things for our parallelograms. 1, 2, 3, 4, 5, 6. So first thing about a parallelogram, we have 2 pairs of sides, of opposite sides. Parallel. 2 pairs of opposite sides congruent. 2 pairs of opposite angles congruent. So we've got 2 pairs of opposite sides are parallel. So this guy's parallel to this, and this guy's parallel to this guy. We've got 2 pairs of opposite sides congruent, which means this one and this one are congruent. So we know that these are congruent. We know that these are congruent. 2 pairs of opposite angles congruent. So this one's congruent to this one, and this guy's congruent to this guy. So that's the important ones, and the ones that they use most often. Followed up, surprisingly, by 6. 6 is used a lot. 6 is 1 pair of opposite sides are both parallel and congruent. So they would say that this side and this side are both parallel and congruent. Be very careful. Sometimes they'll do that trick with the multiple choice questions where they won't stay consistent, and they'll say this side and this side are parallel and this side and this side are congruent. If they do that, that's useless to us. That's not a parallelogram, because it could be a trapezoid. If we take a look at a trapezoid, we've got nice isosceles trapezoid here, which is not snapping into place. Let's try again. Silly isosceles trapezoid. We've got a nice isosceles trapezoid. This side and this side are parallel. This side and this side are congruent. That is an isosceles trapezoid, not a parallelogram. If you want a parallelogram, you have to stay consistent. All right. And then there are the 2 lesser known parallelogram givens, and that would be that diagonals bisect each other. So if I've got a diagonal going straight through the shape, like here and here, that means that this is going to be equal to this, and this one's going to be, oh, that's a trapezoid. Let's try again. Trapezoid does not work that way. We've got diagonals going through the shape. I'll do it in purple. Here and here means this one's going to be equal to this one, and this one's going to be equal to this one. That's what diagonals bisect each other mean. And very rarely do they use this last one. They only use this if you're doing like a mini maze problem. And they use it constantly if you're doing a mini maze problem. If you're doing a maze problem, they will say that consecutive angles sum to 180 degrees. That's only if they're giving you its parallelogram and they give you this angle. This is for mazes. So if they give you this angle is 100, and then you have to find this angle over here, something like that. That's not done in proofs. They almost never talk about that in proof. That's only for maze problems. Okay, parallelograms, of course, had 2 babies. They had the rectangle And the rectangle, of course, has everything that the parallelogram has. So if you are given that it's a rectangle, that means you have all of these things, plus you've got the fact that all angles are equal to 90 degrees and diagonals are congruent. So a rectangle is very good to get because when you have a rectangle, you've got everything that a parallelogram has. So you've got parallel sides, you've got congruent sides, you've got congruent angles, then you've got 90-degree angles and congruent diagonal. It's a lot of stuff for a rectangle. Rectangles are very, very good to get if you get that as a given for a proof. Okay. Rhombus. Rhombus is, of course, a parallelogram. So it has all 6 of the parallelogram traits, and it also has 3 more. Then we've got a rhombus. A rhombus is not known for all equal angles. Rectangle has all equal angles, and they're all 90-degree angles. A rhombus has all equal sides. A rhombus is known for all equal sides. A rectangle is known for all equal angles. Diagonals are congruent in a rectangle. Diagonals are perpendicular in a rhombus. And also we've got a bonus one for rhombus. Diagonals bisect angles. So when we have a rhombus, that's not a rhombus. Let's try again. Ooh, really, really bad at drawing rhombuses today. Okay. When we've got these diagonals, they've now bisect those angles. So that angle is going to be this, those 2 angles are going to be the same. These are going to be the same. These are going to be the same. So angles are going to be bisected, meaning cut it in half. So this full angle here is going to be chopped into 2 equal angles. And then the diagonals are, of course, perpendicular, which means we've got 90-degree angles all the way around. At which point, we can almost prove any triangle in that sucker is congruent. Well, is similar, obviously, because all of the angles are the same. We just need one pair of sides, and hey, look, all sides are congruent. So all I really need to say is rhombus, and you've got congruent triangles of the yin-yang. It's pretty crazy. I love rhombuses. That's why we have the beautiful rhombus, the blue-green rhombus in the back of the classroom. Very important. Okay, and then when a rectangle and a rhombus love each other very much, they make a square. I know, we're not judging. We're not judging. I realize that the rectangle and the rhombus are from the parallelogram family, but they love each other very much, so they're making their square. It's a problem. I know. Rectangle has all angles are congruent. Rhombus has all sides that are congruent. So when we have all angles congruent and all sides congruent, that snaps it into a square. And a square has nothing of its own. It just has things from its family. It has everything that a parallelogram has, it has everything that a rectangle has, and it has everything that a rhombus has. So the square is pretty much the mother lode of all givens. If you get the fact that it's a square, I've got every single thing that I can use from up here. Getting the fact that it's a square, either in the proof or as a given, extremely helpful. So let's talk about how this would actually work with proofs. Once again, all I've done is pretty much redo this for those of you who do not have it. So for those of you who do not have this, this is the chart that we did earlier on and the chart that we worked in our last lab. Okay, let's take a look at proofs. So taking a look at what these proofs would look like, we've got quadrilateral ABCD. This is actually quadrilateral ABDC, is a parallelogram. And we want triangle ABE, so ABE and DCE. DCE. Okay. We want those two to be congruent. So we start our statement reason chart. And of course, the first thing that we have is quadrilateral ABDC is a parallelogram. That's our given. And of course, we've got parallelograms. So the next thing that needs to happen is definition of parallelogram. And this is awkward because there are 6 different definitions of parallelogram, any of which you could use. You could use any of the 6 parallelogram traits. So, what do we want to use? Can literally use all of them, none of them. Now, one of them I automatically said is for a maze problem, so we'll not do that. Let's take a look at the first thing with the parallelograms. For parallelograms, the first thing is, of course, opposite sides parallel. So I'm going to say AB is parallel to CD. So that gives me this side and this side are parallel. Awesome. And of course, with parallel, that means I've got parallel lines form congruent something on transversal. All right, I'm already running out of room. The good news is you don't have to do it this way. There are so many different things for parallelograms. You could go through with parallelograms. You could prove that using this transversal, you could get this angle and this angle. Using this transversal, you could get this angle and this angle. You could get sides congruent. You can do a lot. The best way to do this, however, is not by starting at the beginning of parallelogram and working your way through parallelogram. The best thing is to work smart. I am going to go to diagonals bisect each other in a parallelogram. I'm going to say AD, I'm going to go all the way down to number 4 for this one. And you'll see why. So we're going to do diagonals bisect each other in a parallelogram. And I'm going to say AD and BC bisect each other. Of course, bisect means I need a definition of bisect. Definition of bisect, however, means just cut into 2 equal pieces. So this is my diagonal and this is my diagonal, and they bisect each other, which means this is now equal to this. So AE is now equal to ED. And this guy is equal to this guy because they bisect each other. So BE is equal to CE. That's the definition of bisect. At that point, all I need is some vertical angles right there. Measure angle AEB equals measure angle CED by vertical angles are congruent. At that point, I've got side, angle, side, and my two triangles are proved. Now, some of you are not going to like this. Some of you are going to want to start at the beginning. Some of you are going to say, okay, I want to start. It's a parallelogram. The first thing of parallelogram is this. The second thing of parallelogram is this. And you're going to get all of the information and then figure out your triangles. You can do it that way. It's going to be a really, really long proof if you do it that way, but you can definitely do it that way. And I've had a lot of people do it that way. And a lot of kids really like it that way. Go for it. All you. However, what I want you to try and learn from this particular lesson is there are sometimes easier ways to go about this. You don't always have to start at the beginning. You don't always have to go through every single given that you are given. Some givens are not going to be important on the regions. Some givens are going to be important, but later on in your proof. Because we're going to do multi-step proofs, like where you do one proof and then you have to do a different proof on top of that. So what I want you to do is I want you to look through parallelograms and try and figure out which given is going to be the most helpful. There are plenty of givens, and a lot of them are helpful, but some are more helpful than others, and some are more helpful depending on which triangles you get. So your mission today is just to do question number 3 on the homework. Given that we've got a nice parallelogram, try and prove that those two triangles are congruent. I want you to try and find the best way, the best givens to use for that number 3. That is your mission. That is your homework. Good luck. I will see you all later.